Section 4.4, Matrices, Basic Operations. In this section, we are going to talk about how to add two matrices, how to subtract two matrices, and how to multiply matrices. There's actually two types of matrix multiplication. And we are also going to discuss some miscellaneous topics, including what it means for two matrices to be equal. We're going to talk about something called the transpose of a matrix, and we're going to go back and review really quickly what an identity matrix is. Okay, so let's start on page 1 of this note packet and look at the equality of matrices. Okay, so what does it mean for two matrices to be equal? Okay, so it says right here, two matrices are equal if one, they have the same dimensions. Okay, so they have to be the same size. And then secondly, entries in corresponding locations are equal. Okay, so in other words, the matrices have to be the same size and they have to have the same numbers in the same positions. Okay, so we're about to do example 1 where I'm going to give you a pair of matrices, and all we're going to do is tell whether those two matrices are equal. Okay, but before we do that, remember how we state dimensions of a matrix. Okay, you want to do number of rows by number of columns. Okay, so that's how you do dimensions. So number of rows by number of columns. Okay, and I told you back when we first started doing matrices, okay, you want to remember RC, really cool. Okay, so everything with matrices, it's row by column. All right, let's take a look at example 1. Okay, like I said, I'm giving you 3 pairs of matrices. Okay, all we're going to do, if you notice, there's a space in between the pair, each pair, and that's a space for us to put an equal sign or a not equal sign. Okay, so in example 1, determine which pairs of matrices are equal matrices. Okay, so let's take a look at example A. Okay, so here are 2 matrices. Okay, first let's check the sizes. Okay, so this one on the left, it has 2 rows and 2 columns, so it is a 2 by 2 matrix. Okay, the one on the right, it is also a 2 by 2. It has 2 rows and 2 columns, so they are the same size. Now we need to check that the matrices, we need to check if they have the same numbers in the same positions. Okay, so if we look in the top left-hand corner, we have a 1 in this matrix and a 1 in this matrix. Okay, so the corresponding top left element, those are equal. Okay, now let's check the top right. Okay, so you have a 2 here, 1 plus 1 is 2. Okay, so both matrices have 2 in the top right position. Okay, and then if we check the bottom row on the left, there's a 3 in this matrix, and then 4 minus 1 is 3. Okay, so both have a 3 in the bottom left. And then check one more number, the bottom right, there's a 4 in this matrix, and then 2 squared is also 4. Okay, so they're the same size and they have the same numbers in the same positions. Okay, so these are equal matrices. Okay, all right, when we look at the next one, okay, the next pair, okay, both matrices have the same elements, 1, 2, 3, and 4. However, they do not have the same dimensions. Okay, the first matrix is a 2 by 2 matrix. This guy on the right has 1, 2, 3, 4 rows and 1 column. Okay, because they are not the same size, these two matrices are not equal, even though they have the same numbers inside. Okay, and then lastly, we have this last pair of matrices. Again, both of them have 1, 2, 3, and 4. Okay, and they're actually both 2 by 2 matrices. Okay, so they have the same size. Okay, but we've got to check, do we have the same numbers in the same positions? Okay, so we check the top left hand corner. Okay, this has a 1, this has a 1. Okay, if we check the top right, this has a 2, this one has a 2. Okay, now let's check the bottom left. Okay, this matrix has a 3, this matrix has a 4. Okay, so that's a problem. Okay, the number in the second row, first column is a 3 in this matrix. And in the second matrix, if you look at the corresponding element, so the number in its second row, first column, that's a 4. Okay, so we don't have the same numbers in the same positions. okay? So these two matrices are not equal, okay? So one more time, in order for two matrices to be equal, they have to be the same size, which means they have to have the same dimensions, okay? And then secondly, they have to have the same numbers in the same positions, okay? So corresponding elements in the two matrices have to be equal.